Chemistry wouldn't be anything without the atom, but there are a lot of great scientists that discovered what we're going to learn about. So let's talk about the atomic theory scientists. Up first, we have Aristotle. Aristotle concluded that there were 4 elements: earth, air, water, and fire. And he based this conclusion off of his observations of the world. Now, this may seem very simple, and it was. He's from ancient Greece, but it was kind of the first time that someone thought that the earth was made up of different components. This moves us on to Democritus in 460 BC, so a long time ago, and he developed the idea of an atom, which he called atomos, which is Greek for indivisible, meaning that he thought that it was the smallest particle you can get to. And he thought of this because he pounded up materials in his mortar and pestle until he reduced them to smaller and smaller particles. He figured once you got down to the absolute smallest particle, that would be his atomos, his atom. Now, he wasn't quite correct, but it was the first time people even took it farther and said that each individual thing was made up of smaller particles, which is true. From there, we didn't really have a ton in the way of atomic theory until 1803 with a man named John Dalton. After experimenting with gases, Dalton essentially proposed modern atomic theory, many of the points we still use today. And he said matter is made up of atoms that are indivisible and indestructible. All atoms of an element are identical. Atoms of different elements have different weights and different chemical properties, and atoms of different elements combine in simple whole numbers to form compounds, which he called the law of definite proportions. Then he said atoms cannot be created or destroyed. Now, we've really expanded on this, but this was kind of the beginnings of atomic theory. Then came a man named Joseph John Thomson, more commonly called J.J. Thomson, in 1898. And he found that atoms could sometimes eject a very small negative particle, which he called an electron. So he is now saying that atoms are made up of something. One of those things is an electron. And he found the electron by using something called the cathode ray tube. So he developed the idea that atoms were made up of electrons scattered within a sphere surrounded by positive charges to balance it out. You can see a picture of his model on your screen, and he called it the plum pudding model because it looks like the dessert plum pudding, which I know many of you have probably never had, but obviously JJ was a big fan. So he just thought the atom was a sphere and it had positive and negative floating in it, and he knew those negatives were called electrons because that's what he named them. Then in 1909, a man named Robert Millikan came along. And he actually discovered the charge and the mass of the electrons. So not only did he confirm that it existed, which JJ already knew, he confirmed that it had a negative charge and what its mass was. And he performed his famous oil drop experiment to measure the charge of an electron. The experiment essentially entailed observing tiny charged droplets of oil between 2 electrodes. And he discovered that the mass of an electron was 9.1 times 10 to the negative 31st kilograms. That is ridiculously tiny, like almost zero, so to speak. So based on the discoveries of the previous scientists had determined 2 things, but had to prove them. Something had to account for the mass of an atom, since electrons' mass were far too small to contribute significantly. We had just determined that electrons barely had any mass, but we knew atoms did, so what made up that mass? And since the charge of an atom is neutral, we know they aren't positive or negative, there has to be something positively charged to balance out our negative electron, which we already discovered. But what was that positive charge? So this is where Ernest Rutherford comes in 1910. And he performed the Rutherford gold foil experiment and shot minute particles at a thin sheet of gold, hence the name gold foil. So as it was emitting those particles, the sheet of gold, it found that a small percentage of those particles deflected, meaning they bounced back off, as you can see in your picture over here. Most of them went through, but some of them were deflected. So this caused Rutherford to conclude the mass of an atom was concentrated at its center, that it had to hit just right in order to not go through. So then in 1917, still Ernest Rutherford, he also proved that the hydrogen nucleus was present in other nuclei, which are the center of the atom. And this led to the discovery of the positively charged proton, another part of the atom, and the mass that it contained. So we have now found that positive element and determined that it had mass to it. So then in 1932, James Chadwick comes along, and he observed the element beryllium, and that it released unknown radiation that ejected protons from the nuclei, that center of the atom. And he interpreted that radiation as being composed of particles of mass approximately equal to protons, but without charge. So he noticed that the things coming off were left behind were like protons, but they didn't have a charge to them, but they were about the same size. So he called those particles neutrons for neutral. Pro, positive, neutral. These people were super creative. In 1913, Niels Bohr comes along, and he refined Rutherford's idea by adding that electrons are in orbits, like planets around the sun. So he was saying that while protons and neutrons may exist in the center of the atom, which we call the nuclei, electrons go around the outside like planets do around the sun. And he stated that each orbit was only able to contain a set number of electrons. This caused him to develop the planetary model, sometimes also called the Bohr model, named after him, in which he put all of the protons and neutrons in the center, like you see here, and then put the electrons in orbits around the outside. Now, as we're going to learn, this was later shown to not be completely accurate. However, it is still considered to be the most practical model of the element and is therefore the model we will constantly be using when we talk about elements because it works the best, and you'll see why in a second. So then we had Erwin Schrödinger, yes, of Schrödinger's cat, if you have heard of that experiment, in 1926, where he said Bohr's model was unable to explain many more complicated things about the atom, that it made it nice and simple, which is why we still use it, because we're just teaching high school chemistry here. We want it to be nice and simple. But he said it was more complicated than that. And he stated that the atom consisted of a dense nucleus surrounded by a cloud of electrons at various levels, which he called orbitals. Now, we will use the term orbitals, and we'll be using a lot of the things Schrödinger discovered. He called his model the electron cloud model because he said that electrons do not appear in predictable locations. And now you can see why we don't really use this model as much, because you can see it looks kind of chaotic. So he still has the protons and neutrons in the center. Everyone agrees about that. But he's saying instead of electrons existing in these nice little orbits, they kind of fly all over the place, and we can never actually predict where they are going to be. We just know they are outside the nucleus. And then we had Werner Heisenberg in 1925, and he developed the Heisenberg uncertainty principle. And this relates to our electron cloud model, because he states that it's impossible to know the exact position and momentum of a particle at the same time. Therefore, any attempt to measure the velocity or the location of an electron will make the measurement have no validity. So he essentially said we could never know exactly where an electron was located at any given time. So are you hooked on atomic theory? There's so many more scientists that were involved. These are just the big names that we're looking at. Some other ones you might want to consider researching if you're interested are Wilhelm Röntgen, Marie Curie, Max Planck, Albert Einstein, yes, that Albert Einstein, Otto Hahn, and Glenn Seaborg. They all also contributed, but not someone in a way that you're required to learn about. But I know a lot of you are interested in science, so you can check that out.